In this video, we introduce IT system architecture. Modern IT system architecture relies on interconnected networks where information can freely flow. Organizations collect vast amounts of data. The data is then stored, processed, and distributed to other divisions within the company. The exchange of information is vital to any organization. Without it, they could not conduct business or achieve their goals. Please take a moment to read the learning objectives for this video. Application architecture represents a type of a system that works with the flow and processing of data within an organization, between organizations, or between an organization and its environment. Application architecture is primarily concerned with the activities and processing of program data in the communications between programs. Since the application architecture addresses the fundamental business needs of the organization, the application architecture is typically the primary consideration in IT system design. The use of system concepts is particularly applicable when discussing the various types of IT systems. IT systems are complex and have many layers of subsystems. The analysis, design, and implementation of an IT system must take place at different levels of detail and frequently require collaboration among many analysts and designers. Different application architectures can assist modern organizations and meet their requirements for distributed data or information. Typically, a system distributes or spreads the information through the various components for processing, analyzing, and storing. Examples of system architectures that direct the distribution of information in IT systems are client-server, web-based, cloud, and peer-to-peer computing. The most commonly used model is client-server because of its simplicity. In the client-server configuration, a program on a client computer accepts services and resources from a corresponding program on a server computer. The services and resources can include user applications, processing services, database services, and web services, file services, print services, directory services, email, and remote access services. In simple terms, a program requests information from a server that contains the information. An example is getting your email from a server or obtaining data from a database. The simplest form of a client-server architecture is the two-tier, which implies two levels. Two-tier architecture simply means that there were two computers involved in the service. The basic operation starts with the client requesting information from the server. The server receives the request, processes the data, and sends a response back to the client. Let's look at the web application diagram that we previously examined from a systems perspective, which is a familiar example of the use of the client-server technology. In the basic form of getting a web page, this model is an example of two-tier architecture. The web browser, which is the client, sends a request to the web server for information. The web server then retrieves the HTML file and sends it back to the client, so the web server can display the HTML file in a graphical format. A typical use of the client-server concept within an organization uses multiple servers. A server could be a dedicated server, which is a server that's dedicated to a single service, or it could be a shared server that runs multiple services. In this diagram, S2 is a shared server since it provides application and print services. Dedicated services are the web, database, file, and email servers. An advantage of this client-server architecture is centralization. It keeps the data and services together, which is easier for IT personnel to maintain and control. For example, it's less complicated to back up large amount of data from a local system than from a cloud-based system. Additionally, this model mimics how humans acquire and use information. Typically, we request information from knowledgeable sources as we need it. There are three primary kinds of multi-tier architecture. A tier specifies a level or depth. N tier is used to describe any system greater than 3 tiers. Two-tier architecture is a simplistic form of a client-server model, where two computers are involved in a service. As we discussed, an example is a web server in the web browser. A three-tier architectural model consists of 3 computers, which is a client, and 2 servers. In this model, only one server has some of the information and must go to a different server to get that data. That server then acts as a client. There is no limit to the number of servers in the multi-tier architecture model. An example of this type of architecture is webmail. The web server receives the HTTP request for the web page that contains the user's mail. Before it can send a response back, the web server has to contact the email server using IMAP or POP3 to get the email. The data then propagates back up the chain, allows the user to see their email in HTML format. Note that in this case, the web server machine is the client to the email server. Within reason, separating different applications and processing can result in better overall control, can simplify system upgrades, and can minimize scalability issues. The most general case is known as an N-tier architecture instead of trying to specify how many tiers the system has. Another type of IT system architecture is cloud computing. Unlike client-server computing, the service is distributed among many cloud platforms. Instead of organization hosting or using their own servers, they use servers in the cloud. These services provide off-site storage or processing facilities for an organization. Cloud computing consists of servers, virtual desktops, software platforms, applications, and storage. Common types of cloud computer services are Software as a Service, SaaS, Platform as a Service, PaaS, and Infrastructure as a Service, IaaS. Software as a Service is running software through the internet. Since the cloud-based software does not run directly on the device, it can be cross-platform or run on various platforms. Google Apps is an example of this. You can create documents and edit pictures running software through your web browser. Oftentimes, the server and client share the data processing responsibility, with some processing happening in the cloud and some on the client. Platform as a Service provides computing platforms. In IT, a platform is any hardware or software used to host an application or service. A company can use a cloud platform instead of having a local server that hosts a service. Examples of cloud platform providers are GoDaddy or HostGator for hosting websites, databases, or even operating systems. Infrastructure as a Service provides computing infrastructure or virtualized hardware systems. Information technology infrastructure is composed of physical and virtual resources that support the flow, storage, processing, and analysis of data. IaaS provide the virtual components that connect SaaS and PaaS. Infrastructure as a Service gives an alternative to an organization from having to install new physical computers or networks. Instead, they can use the existing infrastructure to add virtualized components. Peer-to-peer computing is another type of IT system architecture. In peer-to-peer, the computers do not connect to a central server. Instead, they talk among themselves, no device in charge. Each device simultaneously operates as a server and client as they exchange information. There are several disadvantages of this model, including how to keep the list of computers or hosts and their services up to date. For example, how do the devices find each other without the central server connecting them? One way is that each device has to broadcast information about themselves so others can know they are out there. Broadcasting device information works on smaller or isolated networks. Another method is a means of updating a client with the list of other computers, which is how torrents operate. A torrent client does not broadcast itself, but the user tells the torrent software which other clients they have the file. Another disadvantage is the problem with synchronizing data among the clients. A client might not know they're using an older version of a file. The most prominent drawback of peer-to-peer is network security and the risk of viruses. Once a virus starts propagating on the network, it is very difficult to stop. As long as one machine is infected, it can spread the virus to other computers. Aside from the risk, there are advantages of using peer-to-peer. It's easy to set up since there is no need for a server and allows for sharing of files between personal computers, which is how Windows file sharing works. A user can browse the list of computers on the network and then connect to a computer that has the shared resources. The user can then access the data. Unlike a server where there is only one copy of this file, different machines might have a copy of the same file. If one client goes offline, then users can still find the file. Each of the architecture models can work in a hybrid model by combining different system architecture. An example is combining client-server technology with the peer-to-peer. A client connects to a central server to get the list of other devices. Then the computers can communicate peer-to-peer. This method is how instant messaging clients typically work. Other examples are Skype and Napster. The server tells the client how to find each other. In summary, application architecture represents a type of a system that works with the flow and processing of data within an organization, between organizations, or between an organization and its environment. Application architecture is typically the primary consideration in IT system design. Organizations use distributed processing systems to manage their flow of data. We discussed three types, which are client-server, cloud, and peer-to-peer computing. Client-server computing is a model where a client requests information from a server. Cloud computing uses off-site and internet-based computers instead of someone using their own computers. Common types of cloud-based computing are software as a service, platform as a service, and infrastructure as a service. Lastly, peer-to-peer computing is an architecture model where clients communicate with each other without the server.